Welcome everyone to a low level, somewhat open source code, all code GCC LM Clang benchmarking summary. And the last time I've done this was a little bit like 2 or 3 years ago live on YouTube, and I've also done this 15 years ago, also for the German Linux magazine. And while I've worked daily, not only on our commercial products, but also with our Linux distribution, I should have benchmarked it even more, but that is the thing, right? You always think new GCC versions get faster and faster, and then you benchmark it and you are surprised by the results. And certainly well overdue that we do that. And yesterday we benchmarked like the optimization level variants. Today I was more curious about this sort of new x86-64 hardware capability variants. Personally, not the greatest fan. What are they? They are this dash version 1, version 2, version 3. Version 4 I couldn't benchmark because I don't have a new enough CPU here. So this is from a Ryzen, new enough Epic Threadripper 5950X. Obviously that doesn't have AVX 512. But nonetheless, if you work at Intel and want to sponsor a decent Intel CPU, your email is welcome. So what are the results? All right. So you see here, this is OS. Also, I added more and more, right? Initially, I benchmarked this. It wasn't that interesting. People on our Discord, you might want to join, might have seen a preliminary result yesterday without all those variants. So initially, I benchmarked OS for size 02, 03, and then OFast, and the variants version 2.3 and native. And because that wasn't enough, I also benchmarked LTO, and because that wasn't that interesting, I also benchmarked one LTO whole program. And so what are the results? The results are, also this is our open benchmark, similar to spec, just a handful of programs. Also to yesterday, I actually added Lua and JPEG for a little bit more variety, and I will probably continue that because Geekbench is not open source and doesn't support MIPS and Spark and PowerPC and stuff. So our open bench, which I started 2005 or so for the German Linux magazine, probably somewhat useful. So if we look at some results, like set standard, which you partially see, or even lame, they are mostly getting faster, right? This is only one GCC version, GCC 12.01 or so, or 12.1 from current version. And so some benchmarks get faster, like up to some 10-15%. It is sort of what you expect. However, you would have expected more, right? With all those latest and greatest compiler technology and instruction set architectures, you would have expected more than maybe 15%. That is a little bit more. Also, it also shows what I always say, that single instruction multiple data only is beneficial for multimedia stuff, right? Which was initially designed at Spark Visual Instruction Set, PowerPC Ultivec, and Intel's MMX Multimedia Extension, and then AMD 3D Now. Multimedia Extension 3D Now, exclamation mark, right? Only for multimedia stuff, which is also why I added JPEG. All of those benchmarks do not use manual assembly optimizations because we want to benchmark the compiler, not the CPU. So what else does it show, right? So it can improve performance here, lame, and also GZIP somewhat. Also, general purpose code does not profit much from latest and greatest single instruction multiple data, no surprise there. It's not getting that much faster. Theoretically, running a base optimization to run all your binaries, you do not lose that much unless you have very manual hand-optimized multimedia code, which you could build multilib or JIT. But otherwise multilib for having your multimedia code paths optimized. Often, also nowadays, people still hand optimize assembly code for the latest and greatest assembly stuff. You probably recurrently see this, not only memset, memcopy, but all the other motion vector, motion compensation, prediction, 3D stuff, and other stuff we see, also interesting. We see that despite only 10 or 11%, sometimes stuff gets slower, right? While here, for example, as I said, layman stuff. So what is interesting is that OSize with version 2, version 3 native native enabling a little bit more that is available to this Zen 3 architecture. Surprisingly, the next level, OS 01, 02, always in this surprisingly randomly always results in the next level of better performance relative to the instruction set. Improvements there, OS, also SIMD 01, also SIMD 02, 03 and fast, as you see here. But sometimes it gets slower, right? So if we take a look here, GNU PG, for example, there are some outliners which we always had, like even libmet, right? Here, for example, version 2 and then version 3 gets slower, right? I'm really surprised. I saw that in 2005. I'm really surprised that 15 years later with GCC, I probably should benchmark Kling, that you sometimes have the situation where you enable more single instruction, multiple data and stuff gets slower. Although it could be at times potentially be AVX implementation relative to this Ryzen. But there's also a limit because, oh, actually, wait a second. This is a Ryzen 5000 Zen 3. Actually, it doesn't have this half performance AVX. No, then it should not be that. But that is to keep in mind, right? Even for me, I would have thought, not only would I have expected the optimizations to use of more instruction set architecture extensions for more wider, think 512 bits. AVX leads to better performance, but it does not always. Even here, right, look at that libmet, you probably should be how much slower that is, right? Comparing V2, 2.3 seconds, and then 2.8 version 3 in native. Like, yeah, just adding options to the compiler, whether it's GCC or Clang, does not guarantee your stuff getting faster. The next big improvement for me was, I remember a decade ago, OS, like usually 01 was slowest, which pure luck, I added that initially, I didn't have 01 in here. To my surprise, also realignment and reality check. Nowadays, at least on this massively cached and wide architecture that is Zen 3, OS is, in this cases here, nearly always the slowest, to my surprise. And 01 is usually faster. Total surprise. It might be different, and previous videos, maybe I should do that more on older RISC and older architectures. Also Pentium 4 or, although Pentium 4 sucks, think previous last gen AMD or stuff, or MIPS and PowerPC. Whether with slower caches and buffers and memory bandwidth, OS at times is actually faster. The next surprise is I naturally assumed LTO, because actually the last video, that's also you want to share, like, and subscribe and comment, because someone commented, hey, LTO is like, yeah, good point, I didn't benchmark LTO. I only benchmarked like 3 LTO this time. 02 version 2 native, because like just some good version 2 instruction set case here, because version 3 and native at times became slower. And I naturally assumed LTO for link time optimization will always produce better code. And to my surprise, no, it sometimes it does a tiny little bit, but sometimes here it's whopping slower, right? It's like 25% freaking slower, and that's not one time. Here, it's barely any difference, and sets them also a tiny little bit slower, right? And then I read here the man page, who program assumptions, linker plugin stuff. And so they even write here, link time optimization gives relatively minor benefits when used alone. It's like, dude, why, and this is kind of stuff, why do options exist like this? I thought, and I should have benchmarked this, and I regularly on this YouTube channel, right, I benchmark or program work and stuff, and then only with this YouTube channel, thanks to your subscription and Patreon and membership and stuff, I can spend more time and actually produce more interesting videos than just coding around here. And to my surprise, showstopper, right? Why do we even bother with link time optimization when it's usually the same and worst case slower, 25%, right? Turns out there's also full program, -f full program. And so I did that too here for 03. LTO whole program just to see, and yeah, this actually so can improve performance. Not always. For example, JPEG is still slower. Otherwise, yeah, a little bit better than LTO alone. Although there is also another outliner that Lure became a little bit slower, like Dew. They had one job right at GCC and Klang Shu. Recurring theme, I shouldn't complain. We get multi-million-dollar, truth be told, after 30 years of development. GCC, theoretically, if that would be Microsoft or Apple, probably valuated $100 million company of compiler stuff. But yeah, I should not complain because we get it for free. But you have to wonder, they had one job of optimization, and this random result is what we get, right? And build time, of course, so this is runtime. This means the runtime of the code, right? What you want at home, playing along at home for your PC, for your gaming, for your epic thread-ripping Linux distribution, for your PS3, or if you work at Tesla or stuff, your self-driving car and so on. If we look at build time stuff, of course, also what we expect, except two things, also two surprises here. That is, OS builds longer, right? This is the crazy stuff. OS produces slower code, well, size optimized, right? But we spend more time size optimizing for slower code. And at least often here, your mileage may vary and stuff. And then, of course, LTO massively slower, right? I knew that, but I thought FLTO, right? Link time optimization, at least we get better performance. No, not if you just use it. You need to use it together with at least -f full program here. And that, thankfully, is not that much slower again, and sometimes even a little bit faster. Why is he doing more whole program optimization? I mean, maybe it generates then less code or stuff, but so yeah. Build time, the more we optimize, the longer it takes, plus LTO. The cool thing is, I hope multiple, well, except random results and your mileage may vary and real computer information technology and science is difficult. For me, these are two takeaways which instantly, and that's what we're here for, right? Improve, not only I hope it improves your usage of your compiler for compiling your code at home, but it improves two things for our T2 Linux distributions. So one thing is, or two or three things, takeaways here. First of all, our smart optimization. So we have the smart optimization in T2 where we build everything size because the code never runs, and hot paths. So why should I even bother with OS, except maybe for risk architectures? I probably need to re-benchmark everything on the PS3 and HWCAP, previous videos and future videos. So yeah, I probably changed that smart from OS 0.2.3 with all the smartly, smarter and smartest variants that because options and random results. So yeah, instantly making T2 probably better. Also build time, right? Because 0.1, like it's a win-win, right? We spend less time building stuff. So win for me, instead of epic thread wrapping through 350 somewhat packages of cross-compiling them all for our minimal desktop with Firefox. Better build time, faster binaries, win-win, right? Clear stuff. And then the next thing is, because LTO rarely produces better code, I guess I changed the default to also, like, if you enable LTO in T2, because obviously, and that is the thing, right? In my opinion, this compiler options should be smarter, but it takes integrators like this amazing T2 distribution that we work on for over 20 years, like, at least make our options smart and useful. So I change the T2 LTO option because obviously the user doesn't want to know these details, right? The user wants link time optimization, whole program, please, right? So I will change that later today in an hour or two. And then also because I think there is little benefit for me. I had built previously the ISOs with whole program optimization, but if the benefit, even if I change this to LTO full program here, if the benefits are only sometimes barely, and even then it is here at times slower or at least not faster here. It's always, you need to be careful because it's all LTO. Slow, crazy stuff, slower than LTO for crazy reasons, but same performance there to version 2 or 3 version too. I could actually run this one more time and run this whole program actually with... Also, yeah, it gets... Initially, yesterday, I only wanted to benchmark how much performance do we lose with Stack Smashing Protector and Travel Auto var init. And here today we are benchmarking all those variants. It's like, what results? Like the more you benchmark, the more random results you get. It's like, yeah. So 3 takeaways, and making our next ISOs even faster with even smartest with O fast for feeling lucky. And also this runtime. Yeah, we are not using native, right? This are crazy, like you build for native. There must be some crazy, I kind of sort of should report this upstream. There must be some really strange optimization marginality going on there with AVX or so, crazy stuff. But yes, this is also the thing, right? If I build the ISO, in the meantime, I wanted to build 2 ISO variants. Also, not all code is libmet, so other code gets faster. But that is the thing, right? You say optimize native, also other news sites at times, right? They benchmark stuff and native gets slower. And I always like, do they even know what they benchmark? But here we are, my own results, right? Not always, but sometimes there are outliners. And that's the crazy thing. You would think, you tell the compiler, hey, optimize more, optimize for the latest and greatest, and you slower code you get. Yeah, so 3 improvements, and probably that means, as I said, I will not LTO the default ISOs by default, saving me build time. And I mean, there is so much we could do, right? Beside jitting everything, as I regularly say, because when I build, even for myself, right, I have the latest AMD stuff, which you probably want to like and subscribe for my AM5 review as soon as they are out. But right now AM4 5950X, and I can't benchmark version 4 because AVX from 12, which previous video we're not the greatest fan of. And also, this shows multiple things. I mean, obviously AMD 64 was already relatively good, because nothing like the ancient i386. We had 486, 586, and 686. Certainly we had 686 CMove, we are of 586 MMX multimedia extension, first Intel SIMD, although the first MMX sucked. Even 3D Now was better for most things. Obviously, right, AMD already 20 years ago, usually better. And then we had CMove, conditional move, which vastly improved code. And so AMD 64 with all those SSE baseline things already quite capable after 30 or so odd years of 8086 development, already quite some baseline, right? So all this other SMD stuff does not improve that much more. So actually, unlike 686, where we have huge differences between 3, 4, 5, 686, and then 686 with CMove or not, because there were some Wire and Cyrix and AMD 686 clones that didn't have CMove there back in the day, maybe even Transmeter. And so instead of the ancient vintage and retro 386 stuff where we had huge differences for optimization, nowadays hardware capabilities, yeah, not so much. And one last note, not only that I would personally jit this stuff for latest and greatest, but also, in my opinion, this hardware capability x86 version variants a little bit silly, because the name is not self-describing. I personally, like decades ago, 20 years, I always used like MMX, or like 586, 686. It is, of course, a little bit the problem of Intel and AMD that they didn't have clear generations, like think 7, 8, 986. Then we would nowadays, instead of version 2, we would have 786 and 886 and 986 of somewhat generational SSE4 and AVX 1 and 2 and AVX 512. And even then, I would personally have named this baselines, because nobody knows. Everyone, and including myself, we need to go to Wikipedia or your internet search or read the freaking GCC manual or the x86 ABI design document to find out what is included in version 2. The naming by committee, I would probably preferred, or in T2 with our Linux, I always prefer to name the stuff like what major SIMD variant is enabled. For example, AVX, AVX2. So basically, I would have rather named this like x86, AVX, AVX2, AVX712. That maybe it somewhat is like that. Actually, I have a I changed our config because otherwise even I don't know. Let's check. So this is why our T2 optimization stuff was supposed to. Wait a second. This is somewhat. What do I have here? That is somewhat. This is obviously not the wrong tree because I have too many. So it wasn't the latest and greatest. So this was before, and new is that. And that was also the wrong option. New is that here. And so that is also including SEN 2 and 3 descriptions here, because even then I would not know that. So that is SSE 3 and stuff. So that is version 2, adding SSE 3 and 4 and pop count. And then with, yeah, basically, okay, it is a little bit, what did I, yeah, so version 2 basically still not having AVX. So yeah, so I for us to remember, generic is just whatever the first K8 had. So yeah, SSE2 apparently. Where's Ono Corner? Until, yeah, so SSE3, what did I say? SSE2, okay, SSE2, yeah. So generic SSE2 and then version 2 SSE3 and variants, okay, SSE. And there you see, right, it's adding SSE3 and SSE4 and pop count also. Yeah. It's, yeah, probably also not what developers usually, I would say like just JIT it because that is too silly. And yeah, this should have been x86-64, SSE3, AVX, AVX2, AVX712. It would have been a variant more stuff, but yeah, I don't know. Leave them in the comments below. What did I think I had here no corner. What did I probably, also doesn't matter the most. Honestly, you know what, let's, what do we do now? You know what, let's use some AMD because we're on AMD, so that would be something like, you know what, let's take that one. Anyway, let me just copy the last result, 1 second. So let's see, that should have a new, yeah, O2. So what is new? I just copied the LTO O2 will program, at least supposedly, which leads to one even crazier result, that O2 LTO will program is here again slower. You can't make those results up. It is silly. So what did we had here? O3 LTO was at least GNU-PG faster. So yeah, that's not the most stable, reproducible. And LTO, this was a huge work, right? This was, if you, just to put it into perspective, if we would count this at Apple, Google, Microsoft kind of investment, the link time and whole program optimization, certainly multi-million-dollar development of dozens of developers around the world at SUSE and Red Hat and Free Software Foundation and Linaro and Code Sorcery and stuff. And for that, honestly, sure, maybe you find benchmark, or probably you find some other benchmarks. Also, there is a limit, right? How much? Sure, I changed this already a little bit to Lua to have a little bit scripting language and JPEG. And I probably need to add some more multimedia stuff, but it's not the most uncommon code here, right? And for that, a decade later, really have to wonder, they had one job, they kind of like in big tech investment money, they invested millions into program development, link time optimizations, and the results leave a little bit to be desired, to be honest. I probably should do something similar with Clang though, but there is a limit of how much I can benchmark in one day, right? If you found this interesting, we have some comments. Let's take a quick look at the comments. I hope you found this interesting in some way, shape or form, including benchmarking is difficult, time consuming. The results are random, kind of, sort of, not fully random, but at times random. And your mileage may vary, and code and optimization and the whole of computer science and stuff is difficult. Welcome everyone, let's take a quick Q&A. Do you have any suggestions buying relatively high-end ThinkPad? Prices in Europe are so much higher than in the US. I'm in Europe too, totally agree. I said this before, it's a little bit off topic, but go for sales. And also I waited the whole of last year for this 5000 series ThinkPad, whatever it was. I forgot the naming, like 14-inch S or something, AMD Gen 3. They didn't sell it in Europe the whole of last year, and then they sold it in the US, and then even at Christmas also had a sale, which pissed me really off. Like I wait the whole year, and without shipping it in Europe, they have it on sale in the US. Crazy stuff. I don't really have a recommendation. The biggest recommendation is buy it on sale, because the big tech do not deserve to be overpaid. And then obviously size. I can't recommend you subcompact and slim and thin and stuff if you need more power. So obviously if you need processing power and a dedicated GPU or stuff, then that is what you need there personally, right? And so I would also probably not buy last gen, like especially if you buy AMD, there is so much power management development. I would probably wait for current gen AMD availability and sale. That's like, yeah. Do this project also build with Clang using LTO-Thin? Would be interesting. Yeah, of course this should build with Clang. I just don't really have time and stuff. I mean, even this, I just today quickly at JPEG, that already took like basically 1 hour. So like all the stuff takes time, right? Sure, I could use Geekbench, but that's not open source and I can't rebuild Geekbench. I could use other news sites benchmark stuff, but they're also large. I want something where I have a round trip time of maximum 10 minutes or so, and not like wait hours for results, right? This is why, if you're wondering why do I use this small stuff here, then like I want minutes or like tens of minutes of round trip time to make tests and still be able to build on vintage and retro, right? So on an SG Octane, this will build for probably 2 hours, if not 3 or 4. And on a Pentium, it will probably build like 12 hours of stuff, right? And you still, sure, on an Epic Threadripper Ryzen, 10 minutes and you have that, at least parts of this. But if you still want to be able to benchmark your risk stuff for T2 use, then yeah. Yeah, I will add Clang to that. I will probably also sometime soon. So as you see now that T2 is in such an amazing state, and with such extra time and efforts here, we have such a win-win of improving our T2 optimizations. We reach the next level, hopefully, of this YouTube channel, which you probably want to share, like, and subscribe. And then I also want to benchmark like all major last GCC versions to get a better understanding. How did they develop in terms of build time and optimization? Because this is only GCC 12. Would be interesting to see compared to previous versions. Where did we make gains, and where some random losses and stuff. Yeah, I will also add some. Previously, I even had there some quick C++ project in there. But yeah, this is also why I added Lua. I added JPEG. I removed BSIP2, for example. So I will continue to improve this benchmarking a little bit, and certainly adding some C++ project is certainly helpful. I just need to find the right size project for that. So what else do we have? We wasted running after incremental improvements, performing instead of investing in bug fixes and stability. Well, I think bug fixes and stability from compiling everything in T2, bug fixes and stability is relatively good. I wonder more if all this time is spent. Sure, lots of time, lots of things were important. I would have thought, and that's also why we need independent benchmarks, right? If the people only advertise, hey, LTO, link time optimization, and whole program optimization, it is amazing. And then the benchmarks like, where it is amazing. But So this is why we need independent benchmarking to keep those compiler engineers honest and stuff. I more wonder if optimizing the heck out of C, especially because C is like pretty much like glorified assembler front end. There's only so much you can optimize from C. I wonder more what I said previously. Why do we still write code so in such an imperative way and not like some more math formula description, like algorithm describing way for the compiler, like 3D transforms and so on, like how you write algorithms in math, and or like Rust, like more modern languages, like spending so much time on C and C++ when maybe the next best, more important thing are Rust, Swift, Go, and whatnot. But anyway, I certainly appreciate that they spend so much time and effort in it. However, I would have hoped the results are more consistent. LTO and whole program optimization is more consistent, and also the Linux kernel programmers and other even security library authors and maintainers have the problem that GCC and Clang for that matter sometimes break good old code, right? Because implementation defined whatever or C standard, and then they break kernel locking primitives or other kernel whatever exotic constructs and stuff. That is a little bit more annoying for me, because you run the latest and greatest and you have file system corruption or other random crashes and stuff. That is always nice, right? Glocks ask, hey, what's the best optimization stack? Yeah, it depends, right? For me, I mean, sure, you could always, I mean, O fast could also break things, which is not the most desirable. So O fast is a little bit feeling lucky, whether that yields in random corruption. I wonder if I should actually build a Linux kernel with that for a crazy test. So yeah, obviously, usually like O fast native could be the best. Like maybe, I mean, theoretically I could do O fast native, OLTO, FLTO, whole program, but I mean, there are even way more options, right? The combinations are kind of infinite. I mostly, as I said yesterday, I wanted to get an overview how much stack smashing protection, how much security features can we afford without losing too much performance. And this results, I mostly wanted to see the hardware capability x86 variant. And I always get surprising results, right? The more we benchmark, the more surprises we get. The best options depend on your program, which is also why we'll continue to smart optimize stuff in T2, because most code never runs. And even if some setup utility runs, sometimes it literally doesn't matter whether it's a nanosecond fast or not. So I will continue to default to smart test optimization in T2. I will adapt the smart to use O1. Although, I mean, theoretically, we could even make this more optional, but then it also, not every user should rebuild their Linux distribution. And the biggest takeaway for me is I still wish my dream, I probably need to work on myself, who will JIT optimize the stuff dedicated for your CPU. It's not even instruction set architecture, it's also caching and buffers, right? So a JIT could take into account whether to generate smaller code because your older CPU has smaller caches and buffers and stuff, and variants are thereof and so on. Anyway, that's mostly it for this video. Would it be legal to buy from the US since where you wouldn't pay? Well, it is always legal. So of course it's legal to buy from the US, right? But you need to be careful. Some companies will not ship you to the EU. You might need to have a forwarding company, and usually EU member states want VAT for you at the customs, right? So if you order something and it's shipping from overseas, whether that is shipping to the US or EU, wherever you might be, you might end up paying the VAT anyway, right? And maybe if you're unlucky, maybe the US company, even depends how they work, they might charge you some US VAT. For example, if you need to work with a forwarding company where you ship that to a forwarding address in the US, you pay this VAT there to this forwarder, right? If that is in wherever, New Jersey or whatever, you just making this up, right? Or Florida, you pay Florida or New Jersey, whatever, VAT, and additionally you most likely will pay, especially for this high price stuff that is properly declared, you will pay input VAT in your local European country, right? Except when you are lucky, you might at a 10% rate or so chance to get away with it. But yeah, for customers, this is not a thing for customer, right? It's always the seller needs to be in the legal with, so the customer doesn't have risks there of ordering something, except when you order drugs, obviously. But if you order tech stuff, that's the company paying taxes, right? For you, the only risk for you is paying VAT twice or not getting it at customs or the stuff where it's this line. Glaucus asks, what tool are you using to benchmarking? What are you measuring? Startup time. So we are using our open bench that is open source here. My good old code, because it's just totally simple shell scripting code here. And total simple stuff. Welcome to patch this. This is what I mean. I mean, we were benchmarking the whole program executing time, right? Running JPEG, running Lua, running setstandard, GNU time, accounting, user, user cycles they executed. I think that is the most useful thing. But anyway, that's it for this video. As usual, a little bit of discussion. I hope you learned something. I have some T2 improvements to do. And don't forget to share, subscribe. And I hope to see you soon for the next videos, benchmarking and fun stuff to come.